now. And the first thing I want to do is remind you guys, today you got your study guide in, let's look at Josh in 943. You got your study guide in the assignments list today. And with your the study guide, though, I don't need you to focus on it today. Today we're having discussion. We're having asynchronous Monday and Tuesday. That's when I want you to work on your study guide. Okay, I just gave it out to you early in case anybody wanted to work ahead. Okay, depending on what your schedule is. All right, so today we're working on our discussion day, but what I do want to go over before we start is all the due dates. Okay, I want to go over your due dates with you. So the Saving Planet Earth, that video is too old now. Saving Planet Earth, there were 40 film facts. If you have a 0 on that one, it's just going to stick. It's too late. There were about 5 or 6 of y'all who didn't turn it in, and sorry. Okay, and so let's get Laterio in. 944. Okay, yeah, so sorry, that one's too old. All right, but the gray box, page 417, 13.1. Today's the last day for that. And on you guys, there are 1, 2, 3 people who haven't turned it in yet. All right, so the gray box, the last day for that is today. All right, with your notes, I hope to grade those this weekend, but if you hadn't turned your notes yet, today is a 70, which is not bad, it's still passing. If your notes are not in, today is a 70. Also, the TED Ed energy efficiency does have the same date. Today's a 70 on that one as well. All right, so if that's not in, and for that one I did finish grading, but there were 5 or 6 of y'all who haven't done that TED Ed energy efficiency yet. Today's the last day for that. Then the building efficiency, the last, it is, did I say last day? Dang it, I'm sorry, hang on, let me start over because I got you, Dorian. Okay, so I am lost. Okay, so the notes, today's a 70, and the energy efficient videos, today's a 70. Okay, then your building efficiency, today's an 80. Okay, all of those are good if they're not in yet. If they're in, I'll grade them this weekend. Okay, now the study guide today is going to be due on Tuesday. All right, remember that since we're asynchronous Monday and Tuesday, the study guide is your assignment for Monday and Tuesday. It's designed, it's big. It's designed to last the 2 days. But I did give it to you early in case anybody wants to work ahead. Remember, for the asynchronous days, please don't forget to sign in for your attendance. There will be a form there in the assignments list. Okay, all right, so let's go ahead back to our discussion, energy efficiency. The test for this is Wednesday. The test for this is Wednesday. And when I updated the PowerPoint. Remember your original PowerPoint that went with your notes, it was green backgrounds. Okay, that's the full set of notes. That has the detailed information. What I did here with this just short discussion day one is just a light overview type of a thing. I did double check to make sure that all of the test questions were covered in here somehow, some way. All right, so make sure you're paying good attention. All of the test questions will be covered in with this somehow, some way. Okay, and the test is Wednesday. All right, so we are recording this and I'll have this out to you in Remind, and I'll probably put a link in with it in the I've got a discussion days link in there, and I may put a copy of it in with the study guide. I'm not sure. Anyway, so you'll get a copy. All right, so energy efficiency, this is where we started yesterday. All right, so the definition again of energy efficiency is how much work can you do per unit of energy. And again, we use different types of units all the time, but let's say you're using kilocalories. How much good work can you get done for each kilocalorie? Or if you're using joules, how much good work can you get done per joule that you have to spend? Okay, so and I'm not talking joules like video game joules. I'm JOULES. It's a dude who invented it. Okay, I'm not talking joules like rings and stuff. That's not what I'm talking about. Most of you guys remember that from physical science. Okay, all right, so what we also have, energy efficiency. The reason we discuss it so hard and give a whole section just to energy efficiency is because we waste so much. We talked about this yesterday. We waste so much that it could be considered a resource all by itself. We have the bad ones: coal, oil, natural gas, and nuclear. Those are the bad ones. And then the good ones: solar, wind, water, and geothermal. Okay, those are our good we have 4 bad and 4 good resources. Energy efficiency could be considered a whole resource all by itself if we would just stop wasting it. Okay, when we talked about this diagram yesterday, we talked about how this is the energy going in. Okay, we have this is the fossil fuels going in, the nuclear, and this is all of the good stuff we put in. We only put 5% good things into the energy equations that we do here to run the United States. But here's what we get out. Okay, for the stuff we get out, we only get out 16%. That's 9 and 7. The 9% is the good energy, and the 7% is the petrochemicals, the stuff we make from the energy. All right. That's all the good we get out of the system. Okay, which, we put all this in and only getting 16% from it is not very good. Okay, this 41 we talked about, remember, that's the second law of thermodynamics. Every time you do an energy reaction, you're going to lose some of that energy as heat, and there's nothing you can do about it. Okay, that's the second law of thermodynamics. We could make that less, but we can't get rid of it. What we can get rid of is here, this 43%. This is the energy we waste. Okay, and this is what I'm talking about. If we stopped wasting this much, it would be as if we had a whole nother resource available to us. Okay, so that's why, again, that this is so important to us. And not just because it's on the test, and not just because I'm asking you to learn it. It's because you're about to be grown. Okay, you and MLGW are about to have a serious relationship for all the rest of your life. Okay, if you stay here, and if you don't stay here, it's whatever city you're going to. Okay, so you're about to have a really serious relationship with the electric company from here on out, and being knowledgeable about the decisions and what you can do to save your energy will save you your money. Okay, nobody wants to spend, $500 on an electric bill when you've only earned $700. Think about it. All right, so this is what I'm talking about. Okay, all right, so what we need to do is we need to cut energy loss and improve our efficiency. So what we need, this is like making changes to habits, switching devices, going to those Energy Star appliances, or switching to LED bulbs instead of the incandescent bulbs. Try to remember what the words are. Remember, incandescent bulbs, those are the old-fashioned bulbs, and the LEDs, those are the new good ones. And oh, who's that? Darius. 951. There it is. Couldn't find the right line to write on. Okay, got it. All right, so energy efficiency is usually the cheapest way to get more energy. It doesn't cost you much to turn off a light, okay? It reduces the pollution and degradation, because if we stop asking the electric company for so much energy, they'll stop digging so much coal out of the ground. Okay, so it reduces degradation and pollution, excuse me. All right, it's going to slow the atmospheric warming because they're not burning so much, and it's going to increase our national security. We talked about that. If we don't have to rely on the Middle East for oil, for gasoline, if we don't have to ask them for that because we all driving electric vehicles now, or hybrid vehicles, we don't need so much oil, so we don't have to worry so much about what's happening in the Middle East. That's going to increase our national security. The only reason we get in fights with them is because we want their oil. Okay, we wouldn't have to fight with them. We don't need their oil. Okay, so it would improve national security. Okay, hang on, let me get back over here. All right, so a lot of daily activities are wasting the energies. One of the main things that waste, again, is the incandescent bulb. That's the old bulb. Internal combustion engines, again, we're going to talk about that some more in just a second. That's what you call regular cars. Regular cars. Internal combustion engines. We need to switch those to the hybrids and electrics, and we'll talk about that today too. All right, and we talked about the industrial motors, where they are running their motor full speed and then throttling back when they need to do something delicate, rather than having a variable speed motor that if they need something delicate, they just run the motor slower. Okay, so those are the industrial motors. That's one of the things we need to fix. All right. All right, so the data centers, we use that example, and you saw that in the video, running the computers 24/7 when very few people are online, all that kind of stuff. And then we talked about cogeneration. Of course, with the data centers also, oh, sorry, I forgot the data centers, the cooling down the servers so they don't overheat. Again, that immense cooling that they have to have. So all of those things, and you saw that again in the building videos about the data centers. So that's in there. Cogeneration, we said, was when you're using two forms of energy from one fuel source, and combined heat and power is the main one, where when you're trying to create power or trying to do work, then using that heat that's required to do the work to heat not only your building but the neighborhood. The manufacturing industry is one of the best ones to be able to use cogeneration. Again, I'm doing this fast because we talked about it yesterday. The manufacturing industry is one of the best ones, best candidates for cogeneration, with especially with the idea of taking steel, making steel. You have to melt all that metal to make steel. And yes, that's what you're after. But in the process of melting the metal, there's a lot of heat generated. You could heat not only your building, but the entire neighborhood. Again, that's cogeneration, two forms of energy from a single resource. And again, manufacturing is the best choice for that. Okay, then we talked about the smart grid. This is about where we left off yesterday. So smart grids are going to be able to save us money, deliver more efficient and reliable energy to us. There'll be fewer blackouts, fewer power outages. We can get renewable energy better, and we can provide more control to the consumers, the people who are actually having to pay for it. And again, I'm going to go over the details of the smart grid. All right, so again, the whole thing is run digitally. And with the digital center, it can determine where energy is sent when it's needed most. The main example here, where the office buildings are, okay, this is the city center. People here working 9 to 5 and then going home from 5 to 10. So we need more power in the office sector during the day when people are working there, and more power at home. And with MLGW right now, they send the same amount everywhere. All right, but you don't need the same amount everywhere. It's able to make adjustments on the fly where you need more, where you need less, which is why when the power outages do happen, because they can make these adjustments on the fly, who needs more energy, who needs less. If there's a power outage somewhere, they can just shuffle the energy over to them. You won't have to worry about power outages. And then again, this right here is a whole neighborhood full of smart homes, which again, if you guys, we talked about this yesterday, if you guys are wanting to be architects or building designers or civic engineers, and you want to build a neighborhood, you could build them with every one of them with a solar panel on top. Then what happens then with the fact that, during the daytime when the sun's out, the houses are usually empty, people at school or people at home, people at work, the extra energy the solar panels are putting out gets moved out to the control center. They get moved out to the smart grid. It gets sent out to the rest of the neighborhoods, and you get a check because your house just provided energy for somebody else. All right, and then what you do with the solar panels on the houses, which we'll get into in section 2, is you have battery backup. So the sun fills up the batteries, and then you use the batteries over the evening when the sun's down. But also you have a solar panel here, solar farm over here, and a wind farm over here. The main thing about these smart grids that make them so amazing is the wires. Okay, you have the wires are ultra high voltage and super efficient. You don't waste a lot of energy. The electrical system we have right now is over 200 years old. Think about how much electricity we used 200 years ago compared to how much electricity we use now. The current grid system wasn't built to handle all this. Okay, that's why we need this new smart grid system. The wires that we use now, when MLGW is trying to send the electricity down the wires, they don't go very far before the electricity degrades. It kind of dissipates out the wires, it escapes it, and by the time it gets to the houses, there's not that much left. With the wires on the smart grid, they're ultra high voltage wires, super efficient wires, so that they can go big distances. So much so, and this is another thing for the smart grids, that you could have solar panels in the deserts and wind farms in areas like us. And think about the coast of Mississippi and Louisiana. Out in the ocean, you can have ocean-based wind farms and wave farms. Okay, all of those energies, because these wires are so super efficient, you could be sending wave energy from, New Orleans all the way up to here. Or off the Mississippi, because we could be doing this on the Mississippi. When I get to water, my gosh, all it would take, you have the Mississippi River running right here. Just stick a little piece of metal out in the Mississippi, and you just get enough of it. Just pull a little bit in right here, and then let it continue on. As it goes through, you're creating a turbine. I'll talk about more in with, but we could be doing that here. We could be doing water power here and sending it through the smart grid everywhere. Okay, and then they'd be giving us money as far as Memphis goes, because Memphis created the energy, sending it out somewhere like further in the middle of Arkansas, where Arkansas is so flat. Our hydropower from the Mississippi River could be going over to Arkansas. Okay, there's a whole bunch of possibilities for this. Okay, and like here we have electric vehicles. Okay, that we need plugins. We'll talk about that in just a second when we get our electric vehicles. But again, this whole smart grid system allows for so much. And the other thing, consumers have a choice. I forgot to say this yesterday. Consumers are allowed more options because it's digital. The people who are paying the electric bills, the people at home, the people, you guys, can go to their websites and decide, because all of this, it's interchangeable and all of the electricity can flow from one area and be sent to other areas. There could be a time when you are able to say, don't send me any fossil fuel created energy. Don't send me any nuclear energy. Only send me renewables. And you could make that decision on the computer, and they would have to send you the good energy. And therefore, you are no longer taking part in the damage from the fossil fuels. You are no longer taking part in the damage from the nuclear. You could say that because it's computer based. You could make those decisions and those options. It's a possibility to have that in the future. And so if enough people say, don't send me fossil fuels, don't send me nuclear, then the people who are making the fossil fuels, the people who are making the nuclear would stop making money, and they'd switch to the others because that's what everybody's asking for. So that's one of the things that this smart grid would allow us to do. Okay, and it would be so much more efficient, especially being able to shuffle the energy around as it's needed rather than sending it all at one time, full force, no matter if you need it or if you don't. Okay. Yeah. So now let's talk about the cars. Okay. The electric cars and the hybrid cars. Okay. Now, the use of the energy efficient vehicles and alternative modes of transportation is going to improve energy efficiency in the transportation section, obviously. Okay. So did that just go backwards? Weird. Okay. So the thing this is all on the way. Okay. It's already been made. These have already been made. They're already available. Okay, the thing about it is they're a little expensive right now, but I'm going to talk about that in just a second. Okay, what's on the way? Okay, super efficient ultralight cars. All right, gasoline electric hybrid, plug-in hybrid, electric vehicle with hydrogen fuel cell. Okay, now those are the three different kinds. And in your right here, I just have a light overview and a picture. I don't go into specific details on what makes each one different and the benefits and advantages of each different kind, but that's in your notes, in the big green notes that I have for you. I went over specifically each different kind of car. Today, I'm just kind of going over them. But the main thing that I do want to show you is with the hydrogen fuel cells. Okay, the way that they work is you take the hydrogen fuel and you just mix it with the oxygen in the air. Nothing damaging, just hydrogen and oxygen. And when you do the reaction, all that you're left with is water vapor, the same kind of water vapor we breathe out. Not a damaging thing at all. Okay, so that's one of the best positive advantages of the hydrogen fuel cell. You just take the hydrogen fuel, you mix it with oxygen, and all you get out is water vapor. They'd actually done demonstrations on a hydrogen fuel cell car. You know how water vapor will condense back into liquid. They had put a cup at the end of a tailpipe of one of these cars, collected some of the condensed water vapor, and actually drank it. I wouldn't volunteer for that, but it shows you that it's clean. Okay, it's clean. It's just water. Okay, and so knocking down the carbon dioxide emissions would be amazing as far as handling global warming and stuff like that. The trouble is the hydrogen fuel is very, very expensive. And another problem with this is the batteries that they use are very, very expensive. But there's a fix for that too. Okay, think about it. We talked about all the subsidies. Okay, when the government is making us pay for the fossil fuels, they're making us pay for all that fracking. Do you remember talking about fracking and how bad it was in the last chapter? They're making us pay for nuclear through their subsidies. They make us pay for all this stuff that we don't want. If they took all of this money on subsidies and they gave it to the green energies in their research, there is somebody smart enough, and it might be one of you guys, smart enough to figure out how to make these batteries better so that they're less expensive. The batteries, especially for the full electric vehicles, The batteries have to be replaced every couple of years, and they're pretty expensive. So, but I know that there is somebody right now, it might be one of you guys, somebody knows how to fix that, or somebody has a good idea that they could figure out how to make those batteries cheaper, make them last longer. If they had all the money that they're giving to the subsidies for the fossil fuels and nuclear, take that money from the subsidies from them, make them pay their own freaking bills. Make them pay their own bills. Stop giving them these subsidies. Give the subsidies to the green energies. Pay for the researchers so that they can do the research, so that they can figure this stuff out for us, and then it will start coming down cheaper. And so that's what needs to happen so that we can start using these. And so with with this, what I'm talking about are these subsidies, the hidden prices in gasoline. If they actually stopped the subsidies right now, full on stopped paying these guys, this fossil fuel and oil and all this stuff, if stop paying these guys the subsidies, gasoline prices would go to $12 a gallon. That's how much they artificially knock the price down because of these subsidies. Now, I don't necessarily want to pay $12 a gallon for gasoline, but if you stop paying them their subsidies and people start having to pay $12 a gallon for gas, people would start buying the hybrid cars and the fuel cell cars because they don't want to pay $12 for gasoline. We technically are still paying $12 a gallon for gasoline. We are still paying it. It doesn't say that the price isn't there. They say the price is hidden. We are still paying $12 a gasoline, but they have it spread out here and spread out there and spread out there. So we don't notice that we're paying $12 a gallon for gasoline. If you got rid of all of their subsidies and you just paid for the gasoline straight out, it would be $12 a gallon. What they need to do is make that happen. Make gasoline be $12 a gallon, and then people would demand to have the better energy efficient vehicles. Some of these you can get hundreds of thousands of miles on like 2 or 3 gallons of gas. Okay. Not thousands, hundreds of miles on a single gallon of gasoline. Right now, the best they can get is like 54, 55 miles per 1 gallon. Some of them you can get 100 miles for 1 gallon of gasoline. All right. So people would start demanding the better efficiency vehicles. Okay. So that's what needs to happen. But what that is the car manufacturers and the oil companies are lobbying to prevent the laws to raise the fuel taxes. And it sounds like they're doing something for us. Oh, don't raise the fuel taxes. People don't like that. Well, no, I don't like that. Give me an energy efficient car. That's what I would like. Make an energy efficient car affordable. That's what I would like. So then the next part here again is building or expanding the mass transit and the high-speed rail. That's another thing. And when I mentioned it yesterday as well, driving a train, the commuter trains like they have in New York. Okay, so that would knock a lot of people off the interstate. They'd be commuting back and forth on rail. And the way they do it in Europe is they have really high-speed rail. You guys heard of the bullet train in Japan? Really high-speed rail, and a lot of those are maglev trains. Magnetic levitation. And so once you get it going, it doesn't require any fuel. If I'm remembering my physical science right. But these high-speed rails to go from one city to the next city, but in between, within the city, you'd have slower trains or better buses. Okay. So big high-speed rail to go between cities, and within the cities, that is a lot of going on my phone. Okay, that's fine. All right, and within the city, you have commuter trains or, like I said, better buses than what we have. And then to encourage biking, a lot of our neighborhoods now are building bike lanes into the neighborhood, which should encourage more biking. It hasn't yet that I've seen. And of course, I'm too big and round to try it myself, but anybody who's built better should be able to ride bikes. And so that should be encouraged. And a lot of our neighborhoods are building the bike trails. Okay, now obstacles to alternative fuels. Like I said, the batteries are really, really expensive right now, and they have to be replaced every couple of years. However, if, like I said, we stop giving the subsidies to the fossil fuels and nuclear, stop giving them subsidies, make them pay their own bills, take the money you were giving to them, give it to the research in green, give it to the manufacturers in green so that those prices can come down. That's what needs to happen. And again, the reason I'm telling you guys and making such a big deal about it is you guys are about to put all of these votes and these policies and these laws into place. As we go to the voting booths, you guys are helping to make these decisions. So just be aware of the decisions that's being made. Now, so as we go through, these are the different types of cars. And again, the picture's fuzzy, but I go through each of the different types in your notes more clearly. But if you have the big engines right here, these are the internal combustion engines. These are the regular cars going over to bigger batteries on this side. So this next step up is the hybrid electric vehicles. These are something that are a lot more available to most of us right now. The plug-in hybrid vehicles, that's next on the horizon. Now, with the plug-in hybrids or the all electrics, either one of these, if you are plugging in to a power plant, like when you plug it into your house, if the electric company is still using coal, you haven't really done much yet. Think about it. Yes, you're driving an electric vehicle. That's awesome. You're not using gasoline or using much, much less gasoline. That is awesome. But if you are plugging into the electric company and they are still using coal, you haven't really accomplished very much just yet. But if the electric company moves to wind or solar or water where it's available, like I said, we could be using the Mississippi River. We so could be using the Mississippi River. It's like right here. Okay, so moving to solar or wind or water. If your electric company uses that and then you plug in, then you've done something. Okay, so when you're thinking of the plug-in vehicles, be aware that that is based on the electricity that's being made at your power plant. And again, focusing on making sure that those guys go green, then you've really done something. Okay, I think we're at houses next. We've got to hurry up because it's almost time to go. Okay, so green architecture. A lot of you guys are wanting to be architects, okay? And it's really, really awesome, okay? And even if you're not going to fully be an architect, you might get to build your own house. All right, so the green architecture incorporates a number of methods to help improve energy efficiency. We've got using solar energy, which we're going to cover a lot on the next chapter, next section. Adding green roofs and then using super insulation techniques. So what we have there with the green architecture first. All right, the living or green roofs. Let me blow this up a little. You're actually planting, and there's even more pictures in your notes, guys. You are actually planting a park up on top of this building. Can you see this? This is like a big apartment building, and they have a park up. So can you imagine if you lived there and then you went to the roof and brought your laptop to the roof and just sat there and chilled? Okay, or like different parts of that, they had like weddings or outings or something right there on your roof. Okay, and it's green, there's trees and stuff there. You have to be, it has to be specially layers to help protect the roof. I'm trying to get this the right size and in position so we can, wow, that's just going to be a mess. All right, so let's do it this way. All right, so you have to have special structure support because it does get heavy. All right. And but once you've done so, okay, even not just apartment buildings like this, but even regular size houses with a green roof, those plants, okay, what the plants will do for you on the roof, they will absorb the sunlight so that your house doesn't get so hot in the summer. They absorb the sunlight, so it's really, really cool. Then in the wintertime, they act as an insulation. Like the plant's not growing, but the dirt's still there, acting as a really nice insulation. Actually, here you could plant kale or something else, kale and the pretty flowers or anything else. You could plant stuff that would last in our biome. Our winters aren't so bad, so you could plant stuff all winter long. But in most places, it's just the dirt there in the wintertime. But it still adds serious amounts of insulation. And not only that, there's this thing called a heat bubble that happens in the city. Think about in a city how much cars and how much manufacturing and all of that putting out the heat and the asphalt because it's black, um, redirecting heat. You know how hot asphalt gets when the sun hits it, right? All of those things make a city center much, much hotter than the surrounding countryside. If you've ever watched the weather in the evenings, you can see this. Memphis is usually 2 to 3 degrees hotter than it is in the outskirts. All right. And so that's because of that heat bubble with the cars, the constructions, the asphalt. Now, these trees are going to absorb a lot of that carbon dioxide that's adding to the heat. They are going to add shade. They are going to cool down that heat bubble. And not only would it be good for the city if you're doing this and the individual houses in a neighborhood, but that all of that is adding to the fixing the climate change. Okay, trees are amazing as far as fixing climate change for us. Now, the next thing we talked about is super insulation right here. And this is something that can get done on the regular houses. Okay, it's basically hay bales, which is the stuff they feed cows and horses, but there's bricks on either side of it. And what it does, it allows it. Whoa, hang on. Okay, all right. So it super insulation is exactly what it sounds like. The heat doesn't get out in the wintertime and the cold doesn't get out in the summer. Think about how much air conditioning you lose through the walls and through the windows. A lot of air conditioning that you have to pay for, and that you're miserable when it doesn't stay in your house. Okay, this super insulation helps to stop that. So if any of you guys, you may not even need it, like even in really cold places, you may not even need a heater, even just, or a small little heater is all you would need. All right, so this right here is the U.S. green building. So if any of you guys are thinking about architecture or something of that in your future, or if you do get to build your own house, you need to check this website out. Okay. All right. So net zero buildings are some that they create that. Think about if you have like a windmill, a wind turbine on your house and a solar roof on your house. You may create enough energy within your house or business that you don't even have to pull any from the grid. If you create enough within your own house that you don't have to pull any from the grid, that means you probably have a net zero building. And that's what all of us need to be striving for. Okay. Using the double paned energy efficient windows, like I said, so much energy goes out the windows. So those are the single paned, trying to get double paned windows. Facing the house north and south, so that like think about if you have a west facing window, west facing house, in the afternoon the sun comes in and bakes your house down really, really hot in the afternoons, and we don't want that here. So if you face your house north to south, then that will help to take advantage of the passive solar electricity. Super insulation, like we talked about, and net zero buildings will also have low or no energy bills. What if you got your MLGW bill? Most people, the MLGW is $300 to $400 a month. Okay, just in case you don't know that yet, MLGW is usually $300 to $400 a month. What if it wasn't? What if it was $10, $5? What if it was free? What if they were paying you because you made enough energy to share? Okay, so that's a net zero building. Okay, and now, but most of us though are not going to get a new home. Most of us are going to have to renovate an older home. And so these are some of the things you need to do. Uh, Energy efficient windows and lighting, preventing air leaks, replacing heating and cooling equipments with energy efficiency appliances. Remember, when you're looking at appliances, refrigerator, washer, dryer, look for those Energy Star. Your new computers, look for Energy Star, okay? Because you're going to be buying some of this stuff as you get older. Instant water heaters. Now, these are the tankless water heaters. Think about, a lot of us have big tanks of water, and that's our water heater. And the electricity has to keep it hot all the time, whether or not you need it. Now, tankless water heaters, when you turn on the hot water tap, there's an instant boom, it's hot right away. And then when you turn off the tap, the energy stops. You're not wasting any energy except when you need it. It might take just a second to get to you, but not long. Okay, so you turn on the hot water and boom, it heats up the water. You turn it off and it stops. You're not wasting energy all day long heating water that you don't even need. Okay, and then stopping the use of standby modes on our computers. Don't just let it sit on standby so that you punch a button the next morning and it all of a sudden turns on, because all night long it has been sucking energy. They call computers energy vampires. Okay, all day long it sucks energy, even when you're not using it, sucks energy. So what you need to start doing when you're done with your work, turn off the computer. Okay, save what you're working on. Yeah, save what you're working on and turn off the computer. And even better, get a surge protector strip and click that off to be sure that that your computer is not sucking up energy that you don't need. And again, most of us are going to get an older house. Okay, so this is some of the things you need to do. Insulate and plug the leaks, use energy efficient windows, stop heating and cooling the losses. Like I said, with super insulation, heat the houses more efficiently, energy efficient appliances, energy efficient lighting, and then motion detectors. Okay, for when you need to come into a room, don't just leave the room or even outside the house. Use motion detectors. All right, now this one I'm not going to go over with you. Okay, I don't think there's any test questions in this, but I gave you this because, as I said, most of us are going to inherit an older house, and you need this information. Okay, you need this information as you're taking care of your own house as you get older. And these are just some energy saving tips. So that is done. We're done with our notes. We got them all finished. All right, do you guys have any questions for me? I want to take one more picture before it gets too late. Holler off any questions if you got them. Remember that we are print screen asynchronous. Oops, it's fuzzy. Dang it. We are asynchronous on Monday and Tuesday. And on Monday and Tuesday, I'd like you to be working on your study guide. I did give it to you early in case anybody is like panicking and you want to make sure you're making easy hundreds all the time on your test. And like I said, you're welcome to that. You're welcome to work ahead if you want to, but you don't have to. You'll have Monday and Tuesday, save that, in the asynchronous days to work. Okay, I'm going to turn off the recording real quick. Stop recording. And then